Welcome to the Discrete Universe podcast. Today we're diving deep into quantum geometry dynamics, or QGD. It's quite a fascinating alternative framework to Einstein's relativity.
It really is a fundamentally different way of looking at things.
And our mission today really is to break down how QGD confronts the whole concept of simultaneity. That's a cornerstone of relativity, but it also leads to some really mind-bending paradoxes.
Yeah, the relativity of simultaneity is key to Einstein's picture, but it definitely opens a can of worms, paradox-wise.
Exactly. So we'll be exploring how QGD's approach, which is grounded in this idea of a discrete quantum geometrical space, offers a totally different view on what it even means for events to happen at the same time.
Right. And this should be particularly interesting for those of you with a physics background, because we'll need to get into the core assumptions, the nitty-gritty of QGD.
Definitely. Okay, so let's set the stage. Remind us quickly about the problem with simultaneity in standard relativity.
All right, so Einstein's special relativity tells us that simultaneity isn't absolute. If you have two events happening far apart, say lightning strikes at both ends of a moving train, an observer standing on the ground might see them strike simultaneously, but someone on the train, moving relative to the ground, they might see the strike closer to the front of the train happen before the one at the back, or vice versa.
Because the speed of light is constant for everyone.
Exactly. It forces this frame dependence of simultaneity. And while it works mathematically and is experimentally verified, it feels counterintuitive. And it's the basis for paradoxes like the twin paradox or the ladder paradox.
Okay, so that's the relativistic picture. Now, QGD comes along and says, what? How does it rebuild this foundation?
Well, it's a pretty radical departure. QGD starts with two really core ideas that are different. First, space isn't a smooth, continuous fabric. It's fundamentally discrete.
Meaning it's made of tiny, indivisible bits.
Sort of, yeah. Think of them as quantum geometrical elements. The sources sometimes use the term preons. It's like space has a smallest possible scale, a granularity. That's a huge difference from the continuum of relativity.
Okay, discrete space. What's the second big change?
The second one, and this is crucial for simultaneity, is how QGD treats time. It says time isn't a physical dimension like space. It's not something you travel through.
So, what is it then?
It's more of a relational concept. It's a way we order events, a way to relate the states of dynamic systems. Think about clocks. QGD would say a clock isn't measuring some fundamental river of time flowing everywhere.
It's just counting something.
Exactly. It's counting recurrent states or cycles within its own physical system. So time emerges from change in relationships. It's not a pre-existing dimension.
Wow. Okay. So discrete space, time isn't fundamental. That completely changes the game for simultaneity. If there's no universal time dimension, how can QGD even define two events happening at the same time?
That's the core question, isn't it? And the answer is, it largely sidesteps the relativistic problem. Because QGD doesn't rely on a fundamental time dimension, the whole notion of relative simultaneity based on different observers slicing through space-time just doesn't apply in the same way.
So it doesn't define simultaneity in the traditional sense.
It seems less about defining a universal now and more about focusing on the causal structure within this discrete space. What can affect what? Interactions happen via these discrete elements, so maybe simultaneity becomes more about the absence of a possible causal link between two events, given the structure, or perhaps events that are linked in a specific way within the discrete geometry. It's fundamentally tied to the spatial structure and causality, not a shared moment in time.
That's a really different way to think about it. Okay, so let's connect this back to the paradoxes. How does this QGD framework, discrete space, relational time, causality focus, resolve something like the twin paradox?
Right, the twin paradox. In relativity, the traveling twin ages less because of time dilation due to their speed, and crucially, the acceleration they experience when turning around.
The asymmetry comes from the acceleration breaking the symmetry.
Yes. In QGD, the explanation would likely look different. The age difference wouldn't necessarily be attributed to time dilation as a warping of a time dimension. Instead, it could arise from the different sequences of fundamental interactions or state changes each twin experiences.
Because they travel different paths through this discrete space and interact differently.
Precisely. Their motion and, importantly, their experience of gravity, which QGD suggests is instantaneous, affects the progression of these causal sequences differently. Even if gravity's influence is instant, moving through different potentials or simply moving differently would alter the sequence of discrete states for each twin. So you end up with a difference in their accumulated clock ticks, their biological age, because their fundamental physical histories, sequence by sequence, were different.
Interesting. So the outcome is similar, but the underlying reason is rooted in the discrete interactions, not warped time itself.
That seems to be the implication, yeah.
What about the ladder paradox? You know, the one where length contraction supposedly lets a fast-moving ladder fit inside a shorter garage, but from the ladder's perspective, the garage is even shorter and it can't possibly fit. The paradox hinges on when the front and back doors close.
Ah, yes, another classic relativity of simultaneity puzzle. QGD might resolve this in a couple of ways. First, the very discreteness of space might impose limits. Can an object composed of discrete elements really contract indefinitely? Or is there a limit tied to the fundamental granularity? Perhaps the extreme contraction needed for the paradox isn't physically possible in QGD.
Okay, so the premise might be flawed from the start in a discrete space.
Possibly. But also remember the instantaneous gravity aspect we mentioned. If the force is holding the ladder rigid and the interactions with the garage doors are mediated by this instantaneous influence across the discrete space,
Then the whole argument about which door closes first according to different observers might just evaporate.
exactly. The paradox relies heavily on the finite speed of light and how that affects observations of simultaneity at the front and back of the ladder garage. If the underlying interactions are fundamentally different, potentially non-local or instantaneous in the QGD sense, the relativistic setup of the paradox might simply not arise. The question of simultaneous closure becomes ill-defined or has a different, non-paradoxical answer within QGD's rules.
Yeah. You've mentioned instantaneous gravity a few times. That's a big one. General relativity relies on gravity propagating at the speed of light. Gravitational waves are a key prediction and observation. How can QGD propose instantaneous gravity and still match observations, like binary pulsars losing energy exactly as predicted by GR's gravitational waves?
That's a critical challenge, and QGD proponents argue it can be met. The idea is that while the fundamental gravitational interaction, the warping of the discrete space by mass, might be instantaneous, the observable consequences can still mimic effects that look like propagation delay in relativity.
How does that work?
For something like the binary pulsar orbital decay, QGD might explain it not through energy loss via propagating waves, but through the continuous instantaneous gravitational interaction affecting the system's momentum and energy according to the conservation laws operating within the discrete preonic framework. The energy might be redistributed or dissipated within the discrete structure in a way that matches the observed orbital changes, without needing a finite speed wave carrying it away in the GR sense. It's a different mechanism proposed to explain the same data.
So non-locality is real in QGD, but its observable effects can still align with GR predictions in many cases.
That seems to be the argument. It's a subtle but important distinction in the proposed mechanics.
Okay, let's shift slightly. What about the speed of light itself? It's constant in relativity, a postulate. How does QTD explain why the speed of light is constant if space is discrete and time isn't fundamental?
This is actually presented as a natural consequence in QGD. If space is made of these fundamental discrete units, preons, and light is some kind of excitation or disturbance propagating through this network.
Like a ripple moving across tiles.
Kind of, yeah. If the propagation involves moving from one element to an adjacent one, and this fundamental step size is fixed by the discrete geometry, and the process of moving between adjacent elements doesn't involve time in the relativistic sense, then the overall speed of propagation across many elements would naturally be constant.
So c isn't a cosmic speed limit imposed on spacetime, but rather emerges from the fundamental tick rate or step size of the discrete spatial structure itself.
That's a good way to put it. It becomes a structural property of the discrete universe, not requiring postulates about time dilation or length contraction to maintain its constancy for all observers. Those relativistic effects are explained differently or might not be needed in the same way within QGD.
Okay, this helps clarify things. Let's try to really contrast the two views side by side then. Relativity versus QGD on simultaneity and its consequences.
Sure, so relativity. Continuous 4D spacetime. Time is a physical dimension. Speed of light is constant by postulate, leads to a relative simultaneity. Gravity is geometry. Paradoxes resolved via spacetime structure.
Got it. And QGD.
QGD, fundamentally discrete 3D space. Time is relational emergent, not a dimension. Constancy of light emerges from discreteness. Simultaneity isn't frame-dependent in the same way, focus on causality structure. Gravity is instantaneous warping of the discrete space. Paradoxes are potentially avoided or resolved by the discrete nature and different role of time.
Very different fundamental assumptions leading to different ways of handling these core concepts.
Absolutely, different ontologies, really.
Now, for QGD to be more than just an interesting alternative idea. It needs to be testable, right?
Mhm.
Does it make any predictions that are definitively different from general relativity, something we could actually measure?
Yes, and that's crucial for any scientific theory. QGD aims to match GR, where GR is well tested, but it does suggest potential differences. One area mentioned is the nature of phenomena we currently interpret as gravitational waves.
How so?
QGD might predict that these disturbances are not exactly the space-time ripples GR describes, but perhaps have slightly different properties, maybe related to the discrete structure itself, sometimes called preonic waves in the literature associated with QGD. Detecting subtle differences in the polarization, speed, or other characteristics of these signals compared to GR's predictions could be a smoking gun.
So looking for deviations in gravitational wave signals?
Potentially, yes. Or perhaps finding effects related to acceleration or gravity under extreme conditions that might deviate slightly from Einstein's equivalence principle in a way predicted by QGD but not GR. These are avenues for empirical tests, though likely very challenging ones.
Okay, so wrapping this part up, QGD presents a pretty radical shift. It tackles simultaneity not by making it relative, but by fundamentally changing the nature of space and time themselves. It offers alternative ways to think about those classic paradoxes.
It really does, and the implications are profound. If you start questioning whether space-time is continuous, whether time is fundamental, well, that opens up completely new ways to approach cosmology, quantum gravity, the very basics of reality.
This whole discussion on simultaneity really just scratches the surface of QGD, doesn't it? Its take on quantum mechanics, cosmology, a whole different picture of the universe.
Absolutely, it's a comprehensive framework attempting to provide an alternative foundation.
So thinking about QGD's approach, this discrete universe, time is relational, what stands out most to you? Does it feel, I don't know, more intuitive somehow when dealing with events happening across vast cosmic distances? Or maybe less so?
That's a great question for everyone listening to consider. Does removing the absolute stage of space-time and focusing on discrete interactions feel like a more robust way to build physics, or does it create its own set of conceptual hurdles?
And maybe one final thought to leave you with. If time isn't fundamental, if it's emergent or relational, how do we get our undeniable, deeply ingrained perception of a flowing, continuous now? Where did that subjective experience come from in a QGD-like universe?
That's digging into consciousness and perception, connecting physics back to our experience, a really profound question that theories like QGD force us to confront.